On April 1st, we celebrated our 7th year of operation. So that is something like we cherish, and we cherish the support of our customer, our suppliers, our partners, and the way they have helped us in the growth, the way our customers have given us that amount of courage and to work with them so closely. And we I can totally understand the current situation right now in our country and globally. Everybody is sitting at home. More than 3.5 billion people are sitting at home, and such a small, a billion size of a organism has locked up such a billion uh, people. So that is something which gives us also an opportunity to learn, to unwind ourselves from our daily routine and think about what next. Because from the day the world will open again for new businesses, new opportunities will also come with it. And that is what Objectify's major focus has been. If we are sitting at home, let us utilize that time in engaging with our customers better, engaging with our audience better, engaging with the students, the trainers, the people who have been involved with us from a very long time. So we came up with this idea of innovators at home, and we came up with a very basic additive manufacturing, 3D printing workshop, where we will be talking about additive manufacturing, 3D printing 101. So this is like the basics of the basic of the things. So currently, I think Rahul uh, is also present with me. Along with me, Mr. Rahul Pise, Mr. Nishant Kashyap, Mr. Sanka Subrodeb, and Mr. Ashish Jacob from Objectify. They are also uh, they will also help you out with the webinar itself, on ongoing webinar. And during this talk itself, we will be having certain kind of a poll. So Rahul will be initiating a poll where he will be asking you at what level of understanding of the additive technologies everybody is talking about it. But uh, what we have seen in these past 7 years is like it is a journey, and it is a journey where you learn, you unlearn, you learn it again. So that is the beauty of this technology, and this is the time where we can think about it, and we would like to engage better, even though the world is under lockdown. Even though the world is under lockdown, but uh, there is courage between the human race, which is keeping us going. And the way our doctors, our nurses, our medical staff has been performing their activity has been great. And in the midst of it, I'll tell you my personal thing. I just became a father, so I have the best of the time of sitting at home, taking care of my baby girl, and talking to you guys and getting more ideas how we can serve the industry better. So everybody's schedules are now available for such kind of an activity. So let us utilize this 1 hour where we can engage better, and let us take the journey forward about learning about additive manufacturing. So this webinar will be consisting of basics of additive manufacturing, 3D printing 101 class, and then we'll be talking about tools and the rules of additive manufacturing, which is very important, uh, where people try to like from where to start and how to go about it, and what are the things they have to take care while doing additive. So in the media, in other portals, it has been wrongly or very enthusiastically publicized about the technology. It can do wonders, uh, but people who have experience through 3D printing, they might have understood there are certain rules. and with rules come great opportunities, because with the rules you can work in a certain boundary and try to find a solution for your problems. Then we'll be talking about the applications point of it on our third webinar, which will be held on 10th of April. And then we'll be going forward with our learnings and the misconceptions of our customers and our engagers. So it will be a very thorough, very intensive learning curve what we'll be talking about. So fourth webinar will be very much interactive. It will be more considered as uh, like what are the things our audience want to learn and unlearn, and where we can support you better, and what kind of engagement what you're looking for. And the fifth one again will be a dialogue based webinar, where we'll be talking about the current challenges of the technology of the industry and the demand, because every one will not be having same kind of a problem statement. Everybody will be having a different thought of the technology. Everybody will be having a different level of understanding about the technology. So that's why like we will be trying to engage with you guys and try to understand what you understand about the technology and how we can support you better on this. So let me start with the first webinar, which is additive manufacturing 3D printing 101. So here I will try to talk to you about Objectify Technologies. So we were founded in 2013 on April 1st at IIT Kanpur Incubation Center. So it was an innovation and incubation center at IIT Kanpur, from where we started with a very small machine. I'll show you my initial days where we were working out of a 150 square feet room, and from there we have grown into many folds. And I am very much thankful to all the partners, all the engagers, all the ecosystem which has helped us in the growth. And in this beautiful time where we are sitting at home but still scared, we can thank God also, because uh, he's the one who is keeping us going in this endeavor. So we in so how well, in a one line, how we want to identify Objectify as a company. We are an AMESP, so Additive Manufacturing Engineering Service Provider. So from your conceptualization to design to finally executing your project and giving you a deliverable which is directly useful for you is our major agenda. So in this regard, we have been serving industries from aerospace to automotive for new design and development related activity, to medical, new product development, academia, and we also do a lot of training, bespoke training programs for our customers also. Uh, we also serve oil and gas and energy sector, and we have been working a lot with our electrical and white goods suppliers in the meantime. uh, so this is where we start. So this is on your left hand side, you can see a MakerBot printing a Taj Mahal. So this was our MakerBot which we first bought when we started our company, and this was our first print of Taj Mahal. So we thought of starting with something which has which has still a beauty quotient into it. So so here I am sitting with my MakerBot at IIT Kanpur. So this is a 7 years old photograph. So this was our office. This was one of our first order from IIT Kanpur aerospace lab. They were building some UAV structures. So this was our first commercial order. The customer paid almost, I think, 700 bucks for this, but this I will remember for the rest of my life. So that is something how the journey began. So on your right hand side, you can see the current metal setup. So these are like 4 machines right now we have. So we have one M280, 2 M290s with us, and one M400-4. These are some of the projects what we have executed till now. So impellers, brackets, blades. These are like some of pickup automation, pickup glass pickup units, and some of the prototyping on your, you can see auto rickshaw. So this we did for a Piaggio related company, and they have been still using it as a showpiece for their customers. So the highlights of our company has been that we have grown from a two-person company. So I and my brother Arpit Sahu, we both started this company 2 years back. So I came as a graduate from Warwick Manufacturing Group, was working at Jaguar Land Rover, and came back to India. Arpit was just finishing up off at IIT Kanpur as a dual degree physics holder. Uh, and we thought of why not, it is a great opportunity to start something, and starting something has no good time. Whenever wherever you want to start, you can start something. The only thing which will keep you going is the zeal, where you can go and get things done very quickly and very formatively. So from one MakerBot replicator 2x, now we have an array of AM machines, so all sophisticated, all quite expensive production grade machines we have. So ranging from SLA to SLS to DMLS to post processing, CNC machining, so all are under one roof itself. So we are placed uniquely as one of the only companies to have metal and polymer uh, additive manufacturing setup in two offices in NCR region itself. And we have been serving more than 600 plus unique customers across 4 continents. And uh, and so so we have served North America, we have served Europe, we have served the Asian region, we have served Australasia. So right now on our checklist will be Africa, and how come we can go to Antarctica also. So last year itself, we also got our AS9100 RevD certification done for our aerospace customers. So this is a aerospace standard required for our um, uh, customers. So we just got our metal this thing done, and successfully we have done more than 500,000 components on the polymer side, and we have a good experience of 25,000 plus hours on metal additive manufacturing in India. So we take that as a considerable responsibility to showcase what can go wrong, what can go right, and what is the path you can follow for your journey on into the AIM technology itself. So that's why we are meeting today, and we are talking about the same. So
Ankit,
this is the setup. Yes.
just a moment. So, good evening, everyone. I'm Rahul Pise. We are having a short poll so that we are well aware of our audience and their level of understanding. Means everybody has a different level of understanding and different level of experience with this type of technology. So we want to gauge the audience and prepare our further presentations. So the poll will be appearing shortly. Sankha will post it, and there are 5 answers to it. So choose one of it, and then we will know and we will cater our presentation content accordingly. Okay, thanks. Ankit, go ahead.
So I think Rahul has just shared the poll. It is blinking on my screen. Uh, so so this is the current setup, what we have right now at our office. So we are one of the biggest customers for EOS in South Asia, and we have been utilizing their equipments in the metal and the polymer side. In the metal, we are doing the DMLS, which is a powder bed fusion technology. So we have three 250 by 250 by 250 size, and one M400-4, which is 400 by 400 by 400. And we have the India's first quad laser machine. So it has 4 laser in operational side, and we do a lot of post processing. So through our 5 axis available from Mazak, uh, we do a lot of post processing, and we also have a BFW, which is a vertical milling center, um, which is a 3+1 CNC machine. And And we, on the polymer side, we work with EOS P396, which is an SLS system, and also we have a P110. Recently we got a shining 3D SLA, and we also have a 3D systems Project 6000 HD. For quality and check, we use hexagon metrology. We also do a lot of morphology in house, and we take help from our partners. So these are some of the things we are working on. Just hold on. Sorry. Uh, so on the other side, on the design side, because additive manufacturing is as much as possible uh, on the manufacturing side, it is also dependent, highly dependent on the uh, designing side. So CAD generation, the simulation, the the optimization. So we take support on the designing side from SolidWorks and Rhinoceros. We take support on specialized AM data preparation and simulation packages from Simifab, Materialize, and NetFab for our conformer cooling injection molding. So you will get to know more about conformer cooling tomorrow, on our third presentation, where we'll be talking about the applications. So we take help from Moldex 3D for topology optimization and component simulation. So if you have something where you want to do DFAM, we can support you through our MSc packages such as Nastran, Patran, and Apex. So we can give you that kind of a support on something like this. So these are some of our customers, and there are more than 450 plus more customers than these. So we were not able to show them onto one slide itself. So these are some of the prominent names. So there are, like, from ISRO to HALs to Boeing to Honeywell to GKN, everybody on the metal side and the polymer side, they work with us. So any kind of new products is being discussed at least with Objectify for us to engage with them better onto something like this. So these are some of the, I've just got the poll results. Uh, so these are some of the offerings what we do. So on the metal side, we do direct metal laser sintering. We do conformer cooling, hybrid manufacturing, CNC machining. On our polymer side, we do SLA, SLS, vacuum casting, and we also work with our customer for design consultancy. So be it for DFAM, for data preparation as a service, for new material development, reverse engineering, and conformer cooling. So we also came up with a certain engagement with our customers, such as boot model, where we are in talks with our customers, where we build their additive facility, operate it, own it, and then transfer it after a certain time period, so that the customer doesn't have to invest more time in learning the technology. He can start the production in the first go itself, and he can have proven out parts. So certain these kind of an activity we are trying to engage better with our customers, so that this gets served better. So on the product validation side, we do product trials, we do material testing and development. We also can help you out with the life cycle assessment of the component itself. uh, just hold on. So so till now, do any of one of you have any questions about Objectify? Because till now we have only discussed about Objectify. I can totally understand you were not there just to discuss on Objectify, but that is somewhere, like, I also wanted to engage with you and try to understand if you want to know about us also. So do you have any questions further? Rahul? Hello? Hello?
Hello, can you hear
Yes,
me?
yes.
Yeah, so I can see some of the questions and shortlist few. So one about Objectify is they are asking what is the main objective and its goal and its products. So as Ankit has mentioned, we are engineering services provider company. So our direct end use products are not there in market, but we help our customers to do the batch production. So that's the first answer. So uh,
So I'll tell you, like,
yeah.
see, we don't sell any particular product, but what we do is like we engage with you on your project initially. So any kind of bespoke solution. So if taking an example of a customer, he might be having a certain different kind of a requirement from, let's say, a customer is from electrical and white goods background, and he will be having a different kind of a requirement from an automotive customer, but we will be able to work with both of them at the same time, and try to support them with the beauty of the technology, and try to engage better. So in our third webinar, you might where our team will be presenting, you will be showcased one of the beautiful project which we did for our customer, from for our automotive customers, most of them. So from BS4 to BS6 transition, so all the engines getting manufactured in India, all the engine manufacturing companies in India have developed their engines with the support from Objectify, and they have utilized the technology of additive manufacturing. So every customer is unique, every problem is unique, every solution is unique. So we try to engage with our customers so that we come to a conclusion of solving that problem through additive manufacturing itself. I think I might have answered your question.
Yes, thanks, Ankit, for that. So some of other questions I think people are having are about which technologies we possess, and I think you flashed our in-house resources. So
Yes, I
we
did.
have mostly EOS polymer as well as metal machines and SLA uh, and CNC milling for post processing, and we do offer reverse engineering solutions as well. So reverse engineering is not just simply scanning the part, but which type of material it is. And some of the questions as well I saw, do we develop certain solutions around choices of materials and all? So yes, so you will get those answer as we progress. So today is just the introduction, who we are, what we do, which are
And
the technologies we have. So Ankit, you can
mostly we want to engage with you better. We want to understand what level of understanding you have. So in the next round of presentation, in the next round of webinars, we'll be going much more deeper into the topic. Right now we just want to let us be on the same page of the technology itself. So that's why, like, our major point is, so we'll dig deeper in our following sessions also.
One
So
more interesting question was asked was about which are the Indian industry which we have served. So I think that is getting answered in the application presentation on third webinar.
mhm.
So please be having patience for a while. So Ankit will introduce the technologies that we have, how the industry has evolved, and then we will uh, quickly switch the gears up and get into the details. Yeah.
Mhm.
Go
So
ahead, Ankit, now with the main topic.
So here I'll be talking about the introduction to 3D printing technologies, and talking about the classification of the materials and the technology itself, and industry-wise perspective about the technology. And the objective of introducing of additive manufacturing is, it is a kind of a manufacturing process. So it is a not an industry. If everybody has been talking about is as an industry, it is not just an industry, it is a part of a tool for manufacturing. So that's where, like, the major questions of our audience will be answered, is like we have to consider additive 3D printing as a tool to work with our problems, with our manufacturing related questions. So so first of all, we have to understand what is manufacturing. So manufacturing is something starting with the material and going through a manufacturing process where machinery, tooling, power, and labor is involved, and we come out of as a beautiful product, which also gives some kind of a waste and a useful tool which can be installed into a subassembly, or it can be used directly for certain application itself. So manufacturing cycle is very important, where it is about development, baseline systems, production, and logistics. And it also involves the concept of research, analysis, design, and the prototype, and talking about the testing and the planning, because that is very important. When you're ramping up your production, you have to plan your production such a way that you don't have too less inventory or too high inventory. So that just in time concept works beautifully in the manufacturing world. And logistics is very important till the end use of the product. We have to talk about the manufacturing cycle. So life cycle assessment is very important for any of the components. uh, so ancient way of manufacturing, humans have been in love with manufacturing since the very beginning of the human race. We love to reduce our manual labor as much as possible. So we start building some tools just to work with stones. We started working with pouring metal into some shapes, and then started beating up metal just to get those shapes better in application itself. So we have been evolving as a civilization ever since, and manufacturing comes at the right center of it. And we should understand that manufacturing as per se has been evolving every second. So you must have seen the COVID problem right now around the country, and people are coming with different kind of a solution. And that's where the beauty of our race comes in. And we talk more about uh, producing things which are useful for the uh, for the for, for our human race itself. So that is where we come through. So now these days we do some complex kind of structural formation through investment casting, machining, injection molding, direct energy deposition, direct metal laser sintering. So we are evolving as we are evolving as a race. We are also evolving our manufacturing technology. We are getting into more complex structures, more uh, complex problems we are trying to solve for ourselves itself. So these are like some of the uh, manufacturing process which requires certain kind of operations. So manufacturing process can be subtractive, can be additive, can be formative, or uh, it can provide you certain kind of shapes, properties, and surfaces which are easily to be used as an application for your products. So 3D printing is why we call it 3D printing is a basic problem and basic question what everybody talks about. So when we started in 2013, there were a lot of questions. And why why it is called 3D printing, and people used to misjudge it with holographic.
Hello?
Hello, can you hear me?
Yeah, I can hear you. Yes.
Is the
Yes, sir, you're audible
presentation?
now. There's been some technical issues. You're audible now.
No, presentation has gone, right?
Yeah.
Yeah,
Can you
somehow we
restart
can't
it?
see your screen.
Just
Just share screen.
I think I've been logged out.
Hello.
Hello.
Yeah, we can hear you. Go ahead.
Can you see my screen now?
No.
No, sir. Can you reshare the screen?
And
Yes,
now
sir.
we can see.
Yes, sir. You're back.
I think the connection got lost. So we were talking about the different kind of processes and why 3D printing. So people used to confuse 3D printing with like normal graphic related technology, but now everybody is taking understanding of additive manufacturing as the word. So here what you do is like you slice a 3D object into small layers and you try to work layer by layer. So that's why that word of printing, because it is like print stacking 2D sheets in a 3D format. So that's where like that 3D printing word came in. So the difference between machining and additive manufacturing. So subtractive, where you take a billet and machine it, so you have a lot of scrap material, you have a final product. So you take a bigger size billet and you try to remove as much as possible as your desired shape requires. And in additive manufacturing, in other sense, you take as much as material required to make the product itself, where your wastage will be lower. So we have certain examples where we can show you where people have taken a decision not to go with machining but to go with additive just because of wastages. So that is also very important when you go in ramping up your solution itself. So this is a decision curve. So when and where you take additive manufacturing into a consideration. So when you have very high amount of quantities, so you try to engage better with technologies like formative, like castings, die casting or injection molding for the polymer, and die casting for metals, forging technology, something like that. And when the volumes are a bit okay for you, you also try to engage with subtractive, where cost per part will reduce with the number of volumes, but where you require, you don't know the forecast, and where the cost per part is constant and the as per the requirement. So that's where the, like additive technology comes and help you out. So taking an example of complexity versus quantity. So if your component is very complex and the quantity is quite less, you can think about additive manufacturing. If your product is lesser complex and the quantity is very high, then you can think about die casting. If your product is a bit complex and the quantities are okayish, then you can go with investment casting here. But you can take additive manufacturing help in creating patterns. So that's the understanding of the technology, how to use it, where to use it, what kind of a business case you can make through this technology itself is very important. And this is somewhere like, again, if the volumes are quite low but the machinable geometry is there, then you go with CNC. If the volume is low but the geometry is quite complex, then go for additive manufacturing. So this is where like you try to engage with the technologies better and trying to understand which manufacturing technology is better for your application itself. So here what we are trying to engage is on the expectation curve of additive manufacturing, and from like how people have been talking about it. Everybody used to tell when we started in 2013. There was a person called Bray Pettis. He was the founder of MakerBot, and he used to tell that in every home, in every classroom, in every workshop, a 3D printer will be there by 2020, and this is 2020. Uh, there are more specialized applications for additive manufacturing. There are more service bureaus. There are more thought leaders on additive side, but it is not that kind of a case. So there was a sense of inflated expectation which came down, and people started to understanding like, no, we cannot answer all the questions of time, quality, and price through additive manufacturing. We have to select certain application where these kind of applications can get into uh, production, serial production, or small batch production for themselves. So right now we are in this plateau of productivity. So a lot of automotive applications, companies like Audi, BMW, uh, Bentley, they have found some components which they can small batch production. For that, they can use additive as a small batch production tool. In aerospace, there are a lot of companies right now discussing additive as one of the supply chain disruptive. So every industry has a different problem statement. So how well you answer that problem statement through the technology is very important for you. Uh, so till now, if somebody has any questions, I can take up right now.
So, yes, so some of the questions. Hello,
Yes.
can you hear me? Yeah, so some of the questions which are interesting they are asking is what procedures we follow in order to understand uh, whether conventional process is better or additive manufacturing is better, and how do we do the reverse engineering if certain part is already produced and has to be duplicated. So that's the question.
Okay. So see, choosing a manufacturing technology has been a question ever since. So if you are choosing on, let's say, if you talk about only metals, so everybody should understand what is manufacturing. First of all, everybody should understand what kind of manufacturing process uh, we should work with. So I'll give you one small example. Uh, like 300, 400 years back, uh, we never used to have these kind of factories, like centralized factories. So in every village there was a cobbler, there was a mason, there was a blacksmith. So everywhere there was a forging guy. So everybody used to know like from where this chair is made from, what kind of a technology, what kind of a hard work labor that guy has taken into. But now as the factories are getting centralized, things are getting made out of China so much, nobody cares like how things get produced. So a lot of people have a lot of undue understanding of the manufacturing technology itself, and that's why like we should also think of technology uh, around ourselves, and we should not take it for granted. As I'm sitting on a chair, I should know how this chair has been made, so that I can respect the work what we do. So answering your question, how to understand which kind of technology is good for you. So I have prepared a chart where you can select first is the application, then the material, then you can go for the process, and then later on you can go into assembly and go forward with producing the number of quantities required for your project itself. Any other right now?
Yeah, another question.
Yes,
uh,
the reverse engineering you were asking, I think.
yeah, reverse engineering. So manufacturing choice is one thing that you described very well, but how, if certain part is already there in market and because of certain constraints, means maybe it is outdated part, nobody is producing it, or nobody is willing to agree for making very small batch of 5 or 10 pieces, So that's where our technology can help,
So,
right?
so yes, it can help. So there you have much more prerequisite requirements. You need to understand what is a reverse engineering, what is 3D scanning, what is redevelopment of the design. So if you can work till the point where you can get the design ready, where you can get a 3D model ready, where you can get more details of the product ready, where you can understand the material uh, currently used in that product. So this is called reverse engineering. So reverse engineering is not just 3D scanning. It is this whole activity of creating an engineering drawing to CAD model to understanding of the material and the tolerances required for your production. So you have n number of tools, you have n number of experts who can support you of that domain, and what kind of a product you are working on. So that's why, like, your engagement on the reverse engineering side should be different, and then you can come to additive and then try to check on the process, check on the materials, select those materials for your application. Might be a case that material cannot be produced right now through additive. There is certain kind of a development required, and that's where, like, a company like Objectify can support you in understanding your problem statement and trying to engage better uh, with you in your application itself. So it is a very subjective question of how you can do something like that. It has to be defined through the product itself. So it is a bespoke problem right now.
So
Now, yes.
there are certain questions as well, how to decide if technology is matured enough for mass production versus a batch production. So which are the AM platform available for mass production? That's the question.
Mm-hmm. uh, See, every technology has its own limitation. So mass production for automotive is in millions. For aerospace, it is in
Thousands.
not even thousands. Also, some of the mass production products, if you see, will be somewhere around like 200 to 250. So every industry is different, every requirement is different. So we work a lot with the space agency, and space agency has only production requirement of 4 pieces, 5 pieces. So that's why, like, the beauty of the technology comes in, and that's why, like, they also save a lot in producing the component in right time for their application. So that's where, like, the point is, like, you should know what application, what kind of numbers you're talking about. Then we can uh, give you a heads up that this technology is feasible for you or not. Because, see, there is a three-sided matrix which is useful for any of the product you want to define into. So it is quality, time, and cost. So if it is cost effective for you to produce in AM, it should be produced in AM. If it is quality which no other technology can work on, then AM again is better. And if you require the component very fast compared to other technology, where you will be investing a lot of time in investments in tooling, in designing, in production of the tool, and then you will be waiting for uh, n number of quantities to amortize the cost of the tool. So that's why, like, the additive side comes in. So whenever you can have a elastic kind of a requirement, and you can sustain your production accordingly in additive.
Just to add one my input, Ankit, as well here. So it depends on what is the fixed cost and the variable cost. So the fixed cost in conventional technologies is a fixed automation. It needs a tool in order to do the uh, repetitive production of the same components. But when high complexity variety of shapes are to be produced with the similar sort of quality, means low volume but high mix, that's where the current adoption of these technologies are. So you cannot compete with the injection molding for maybe a consumer goods like a water bottle cap. So that wouldn't be a solution via 3D printing. It is a self-defeating effort. So
Hmm.
you have to make those wise choices. So amortization is a fixed cost, that is the capital expenditure, and then there is a operating cost. So there is a sweet spot where you can cross over with additive manufacturing. So as you see that two curves overlapping, and that's where you can say it is a break even. So additive manufacturing is matured enough to break even with the conventional technology. So on that front, we can help organizations with our analytical abilities. So we have application engineering team, and they will take a look at your specific case study, go through details, and prepare the numbers to make a informed decision. Okay.
So I have a very interesting question from one of the when Rahul was talking. I was just reading. Do we plan to build a vehicle using 3D printing? Yes, there has been a car completely manufactured out of 3D. So there's a company called Local Motors in US who does the complete frame of the car through FDM technologies, and there's a British company, Singer 21C. So there's a Top Gear video, you can go on YouTube and you can look into it. So they have made a hypercar, so a hypercar like Bugatti Veyron. They have made through additive manufacturing. So if somebody comes to you and asks what is the level of integrity of a 3D printed component, you can just show them that video and try to engage with them better. Like, yes, there are certain kind of things which you can do with this technology which you cannot do with any other technology itself. So one other question was like, which material is used in 3D printing and how to validate a final product, what factors we consider for validation. So so validation is on the application itself. So till the point the last application engineer validates the material, the process itself, the validation process is not complete. So we do a lot of testing trials, so a lot of tensile coupons, a lot of mechanical testing, chemical testing, uh, uh, kind of things which we do, a lot of tomography, uh, which we do for our customers, for them to have that level of confidence into the technology itself. So that is where like we work very closely with our customers, try to understand what will be, what we should do differently for them to take it in the production stage itself. So that's why like what we try to engage better with our customers.
Ankit, one more interesting question, then we can move on to the presentation. So the last
Yes.
question was about, uh, we will be interested in knowing what all are done in BS6 upgradation projects through AM route. So how we have assisted Indian industry to go through this slowdown that we saw just before the corona outbreak. Auto industry was going through certain changes in terms of norms. So please
See,
elaborate.
the main thing, I'll tell you, you asked this question, and actually, we were supposed to do this. I spoke about BS6 right now, but we were supposed to do in webinar number 3 about this.
Yeah.
So I'm going to answer something like that. So as Indians, like we take some pride in mitigating problems quite quickly. So that's why like um, all the automotive companies in India, they had questions about additive manufacturing, and which is quite it is not shocking for us also that you are skeptical about a technology and everything. But when the time is right, then all the skepticism changes into optimism. So this is what we experience with a lot of our customers, where they were very skeptical about the technology initially, but all of a sudden they had 11th hour problem, like they needed to produce so many engines before March 2020. They never knew that corona will hit us. So the deadline was March 31st 2020. So they started thinking like somewhere around 2017 and 2018 beginning, that how can we uh, produce so many engines by March 2020. So what they started doing was like they were not ready with the designs even. So they had to invest a lot of time in designing, and only thing they can reduce time is into like testing and trials. So producing of a testing trial component through investment casting or die casting will take its own added time. So what they thought was like, why not they can just 3D print these initial batches just for their trial and testings, and they can just use it on their engines for their trial activity. So these were in numbers somewhere around like 50 to 75. So such engine components, so from crank covers to housings to casings to cylinder heads to the complete cylinder blocks, so we were able to manufacture these for our range of customers who were involved in the BS4 to BS6 transition. So this is how Objectify played its role in this national emergency in the automotive space. So we are in love with the the media right now is in love with a word called emergency. Yes, industries are also in emergency sometimes. So this is the way certain emergencies help you in engaging better.
Okay, so thank you for answering that question. And now we can proceed with the rest of the presentation. And at the end, we can, if time permits, have a couple of more questions. So you can go through rest of the presentation.
So this is the timeline of additive manufacturing. As you can see, in 1986, Dr. Chuck Hull, who was also a founder of 3D Systems, he he first invented an SLA equipment. That's why still we use SLA means stereolithography. That's why still we use a extension called .stl. The full form of .stl is still uh, stereolithography. We still use that uh, term with us in which is carried from 1986. So from then, the first FDM came into the picture in 1989, and a company called EOS in Germany got formed by Dr. Hans Langer, and is he's another visionary of our small industry. Again, what I'll say is a sub industry, not as per se like an industry itself. So so then the biggest breakthrough in the industry has been 2007. You name it or not, Dr. Adrian Bauer from University of Bath. It is not mentioned in the presentation. I met Dr. Adrian Bauer personally, and what he did, he started this open source platform for FDM, and that actually ignited the whole industry. As you can see, the mobile industry after the Android coming into the picture got ignited, and everybody in the world is using an Android phone. So after the RepRap movement started by Dr. Adrian Bauer, the movement of open source learning and collaborative approach, which is a new world order right now of collaboration. You can see in the corona phase also, everybody's collaborating from WHO to such big organization, everybody's collaborating. That's why the development also gets faster, and right now the tools are very good of sharing information. So internet, as we are sitting right now in front of I'm sitting in Delhi and doing a webinar globally. So I can see some of our uh, attendees from out like overseas attendees also. So that is somewhere like the information can flow better. So after that, lot of activity happened on the consumer side of 3D printing, and also on the uh, engagement with larger organization like GE, Rolls Royce, on the medical side with GE Healthcare again, and companies like Siemens. So that kind of an engagement push the industry for their development, and right now we sit at almost $10.2 billion as a net worth of our industry, sitting in March 2020. So that is the level of development, that is the rapid development which has happened in our industry itself. So what I want to say, like till 2011 the industry was sitting at $1.2 billion. So from 1986 till 2011 it was sitting at $1.1 billion, and from $1.1 billion in 2011 to 2020 we are we have gain 10 folds again. So that is kind of a growth rate. Every analyst, every investment banker, uh, every market researcher is looking at as additive manufacturing as a very robust industry to be an investor as. So I think we were at the right time at the right place. So some things are bound to happen. So this is a 3D hubs graph. You can see down below. I have not removed the logo of 3D hubs. It is a beautiful chart. You can go, because I was not able to uh, download it better, but it is one of the most beautiful chart where it characterizes different technologies, and the technologies from vat polymerization to material extrusion to material jetting to binder jetting with powder bed fusion, direct energy deposition, and sheet lamination. So different technologies come under uh, different names, and different feedstock for different technology itself. So vat polymerization will have a liquid based resin. Material extrusion will have like wire kind of a feedstock. uh, Powder bed fusion will have powder in it. So it is on the polymer side also and the metal side also. You can have polymer also in a powder form, and you can sinter that powder into layer by layer, and you can produce components. So that technology is SLS and MJF, which is greatly utilized by EOS and HP right now. And technologies like DMLS, SLM comes under the uh, concept of powder bed fusion. So EBM is electron beam melting. So that also comes under that umbrella of powder bed fusion itself. So, so here you can see one of the most beautiful part is in this illustration is like they have also mentioned the companies which are involved in different technologies. So you can see one company running through the presentation itself is 3D systems. So one more reason why it is still called 3D printing is because of 3D systems also. They have that brand equity to run through, like we say Pepsi for any of the aerated drinks. So 3D systems got involved into the technology as they were the founder of the technology, father of the technology itself was the founder of this company. So it ran through their genetic makeup, and the technology has been still been called 3D printing itself. So this is like process selection, how and why you can take the processes. So there are like two types of feedstock can be given. One is in the liquid form, one is in the solid form. So in the liquid form you can do polymerization or in binder jetting kind of thing. In solid form you can have uh, uh, powder form or filament form. So powder form for powder bed fusion, SLS kind of technologies, DEDs, and filament form, something like BAM, wire arc additive manufacturing, and FDMs, sheet like LOM, laminated sheeting. So here just illustration of SLA. So stereolithography as a process. So here there is a vat, and that vat gets solidifies through an ultraviolet UV source, and it solidifies into certain areas and develop the component vertically itself. So it is a very wonderful technology to be utilized in different applications. Right now, one of the world's biggest company for making aligners for your teeth. Um, if somebody would have used in their teenage. So there's a company called AlignWise, which is an American-based company. They make millions of aligners through this technology itself. So I think selecting the right application for right process is very important, and certifying that material for your application is also secondly very much needed for your application itself. So here we are talking about SLS. So here a laser source uh, uh, sinters a powder layer, and the powder is recoated by this recoater. So every time there's a recoated layer, so the component goes down into the build itself. here you don't require any kind of support. As you can see in SLA you require supports, but in SLS you don't require support for your because it is self-supported by the powder itself. And powder bed fusion, you again are melting powder at a with a very strong laser source. So these lasers are mostly vibranium lasers, mostly in the range of 200 to 400 to 1000 watt laser. So very high level of laser requirement is there just to melt the metal powder and reform into a meaningful shape. The technology is much more similar to what SLS is. So, but you can understand it through the technology itself. So again, here we are again talking about material selection, process selection. So process selection is also dependent on the material. It is also dependent on the functionality of the component. So if you have a requirement in the polymer side, you can go into a thermoplastic or a thermoset kind of a setup. If your requirement is in the metal, you can think of utilizing DMLS, binder jetting, VAM, or DED. Uh, and according to functionality, it is a very needful this thing. If it requires only form and fit, you can take FDM, SLS, or material jetting. If it requires very high strength, you can take FDM, SLS, DMLS. If it requires some special properties like chemical resistance, you can use SLS. So it is a very wonderful chart of process selection where you can select your process according to your need itself. Here we are talking about the properties of the materials from nylon polyamide to the gray nylon, which is right now in HP material, to glass filled. It is a 30% glass filled material, to Vero white and Vero clear. So these are all SLA related material. So you can choose the material according to your application. So if your requirement is on the tensile side, so you can check on the values of your requirement and then choose a material accordingly and choose the application accordingly for your requirement. So nylon polyamide is also a biocompatible material. So right now we are currently working with some of the corona testing device companies, and we are utilizing this material for the application of it, and we are able to serve the industry and the country better. Again on the
Ankit, yeah,
yes.
we are at a 1 hour mark, so it's already 6 p.m. now. So we can
I'll just take 5 minutes. I'll just take 5
yeah, we can wrap it up and open for more Q&A. So there are
minutes.
much
5 minutes.
interesting questions as well. Yeah.
5 minutes. Yeah. So on the metal side, again, so there are blown powder technologies, there are wire feed technologies, there are powder bed fusion. So powder bed fusion is the most popular metal technologies, but LMD and VAM, they are coming up very fast and they are gaining a lot of traction in bigger components and bigger application itself. So right now we can do materials like SS316L, nickel superalloys, titanium, aluminum. Right now in development are copper, manganese, gold, silver, platinum, refractory alloys like molybdenum, uh, tungsten, and metal matrix composites. So what I just wanted to conclude with is what are the things we should consider while talking about the additive technology. So we should have four things very important: is man, machine, material, and software. So we should have rightly skilled team with understanding of what is a design. At least they should understand what is a design. Then the machine and the process, you should have the right machine with the right process in it, and it should have also good material which serves your application better. And you should also, because 60% of the complete work is on the design side, so man and software works in tandem, and material and machine work in tandem during the process itself. But the man has to decide what software has to be needed to fulfill with which machine and with which material. So this is a complete uh, condensing of the data of what things are to be taken care while you are doing additive manufacturing itself. And so what I would say, because I can see a lot of newcomers um, in this webinar, like who are new to the technology itself. So what I'll tell you is like the prerequisites of for additive manufacturing as a technology to understand, or if you want to start a new career into it, you should have a good knowledge of design. You should have a good knowledge of CAD, how a 3D model works, because that is the bread of additive manufacturing itself. You should understand what are the different manufacturing technologies and how to select a right manufacturing technology for your application. You should also have, very important thing is opportunity. Uh, and for that opportunity to come to you, you should have a good eye to look into your work profile. And last, which is the most important thing in any industry, is making money out of it. So creating a business case is where for any component, if you're doing prototyping, if you're doing in a direct application, if you're doing a replacement component, it should make a business case. It should be a commercially viable component. It should be a win-win situation for the end user and for the uh, industry itself. So that's where like that understanding should come into the picture. And so I'm just ending the topic, as Rahul just mentioned that I have passed my allocated time. So thank you so much. If you have some more questions, you can write to me directly on ankit@myobjectify.com. And you can also write, if you don't want to directly come to me, if you want to have a open forum kind of a thing, you can write to marketing@objectify.co.in. My team will be taking care of that activity um, for you guys. And on 8th, we'll be presenting again at 5 o'clock with tools and rules. We'll be digging more deeper. We'll be talking about the tools required, the zeal required, the process required for uh, taking up additive manufacturing projects itself. So any questions, please?
Yes,
Now you can.
Ankit, thanks for a very robust go through and introducing people. So I see a lot of people are hungry. So we have 64 open questions and 41 I could answer via text. And I had to reply to many people that uh, uh, have a patience for webinar 2 and 3. That's where most of the questions will get answered about how we do the uh, cost estimations, what are the pros and cons of choosing one technology over another. uh, all those will be getting answered in next session. So today you just got introduced who we are, what we do, what are the possibilities out there in the world with the different choices of technologies, choices of material selection. So based on each specific case study, we have to select the appropriate, and the selection and uh, then putting that into practice is something we will discuss. And not just putting it in practice, we will show some of the end use applications that our customers have already been using in the field duties. So that is something more yet to come. So please do write questions to us that will help us prepare to solve your curiosity, as well as we look forward to work with you. So some of the questions that we could take for another 5 minutes, I can ask those to Ankit. So first question is, are there any sort of waste involved in additive manufacturing process? Could you describe the support structure and how that is a very low amount of waste in comparison to a throwaway cost of a tooling or uh, breakaway molds? So can you describe? Yeah.
So you have a given amount of waste also. So the biggest waste right now will be like unutilized powder or the support material you have produce with the component. When you will be removing that support material, that will go as a waste. So there are right now companies trying to engage better on utilizing that waste material also. So on, it is similar in polymer and the metal side. So people are trying to engage better on material saving of the waste itself. So there is, yes, there is waste.
Yeah,
involved.
thanks. Another question which is very interesting. People are asking, uh, although the speed of printing is quite slow in comparison to injection molding or those type of fixed automation, so why do you call it as a rapid prototyping?
So rapid prototyping, if compared to injection molding, in injection molding you have 4 to 8 weeks of making a mold kind of a lead time. But if let's say if there is a customer, so I'll tell you, while we were doing this first project, I have one customer who has been since 2013, and he makes certain devices which are fitted in the shoe for tracking in mines and those kind of regions. So his volume has always been almost like 200 to 300. So he has never, in past 7 years, he has never taken a decision of going through injection molding, because his requirement has been very elastic, and his investment into an injection molding tool will be a very costly affair. And wherever he needs that kind of an elastic demand, he just orders with us. So that kind of a thing is a very bespoke level of problem which can be answered in a very bespoke solution way. So injection molding has a very high lead time in development of the tool. Here you can start the production if you have a design ready and it is okay from your end. We can start the production and we can deliver the first component within hours or within days itself. It will not take weeks.
Thanks. One more question. So, how accurate are the part dimensions when 3D printed? So, can you elaborate on that one? So, this is very loose question, I would say. So, most of these questions will get answered in second webinar we are having. So, where I will tell layer of thickness, because of layer thickness, how the accuracy will be different, and it we will discuss this in much more detail. So, could you just briefly tell a overall top line summary? And I think we are running out of time. So, first of all, thanks everybody. We had been looking at the questions. Many are still open, so we'll try to answer them in phases. So 3 presentations are where you will get most of the questions answered, but some of the questions are tough ones where we need to elaborate and have misconceptions answered in a more dialogue fashion. And that's a kind of a fourth session where we are resolving the misconception, sharing our learning, and ultimately there are challenges as well. So uh, the, the world is as big as we get amazed by, and sky is the limit for any sort of problem solving. So we can keep it pushing further and further, and there are plethora of opportunities coming up as well. So we will get into that. And first of all, thanks. And next time we will have a short poll. How was the first session? So do join our second session. So one last question is uh, about the cost. So many people have asked that sort of question. So how competitive we are, and how we help people to have a realistic expectations about the cost of uh, part productions, and how we make them comfortable to adopt this technology with a set realistic expectations, so that there are no disappointments. I hope there had been cases. That's the misconception. If wrong advice or wrong consulting happens, then people get negative experiences. So that's the reason why I think this question is popping up. So would you just answer that? Then we will call it a day. Thanks for everybody. Yeah, go ahead, Ankit.
Can you repeat the last this thing?
So the question, last question is about costing. So how we are engaging with our Indian customer partners as well as overseas customers in order to go on the journey of adoption of these technologies and making it viable in their supply chains and their value equation. So that is something people are asking.
So the biggest thing is like, as I'll give you one very fine example. I think there are a lot of my friends from uh, ISRO also, I can see. So in this webinar itself. So I'll give you one small example of ISRO itself. So one of the biggest organization of India, and their journey in additive has been remarkable. Their understanding of the technology, as you might be understanding that ISRO has been more towards material scientists, and the amount of successful projects they have executed in the world. So they are respected all throughout the globe itself. Their understanding of the technology, I have seen in these 4 to 5 years of engagement with them, has increased so much, and their confidence is everything. So what basic thing is, like, if you do a garbage in, you'll get a garbage out. So that is the good thing about our people, is like they give you the right information, they give you the right kind of expectation. So the expectation part has to be defined better from our end, and their requirement part has to be defined from their end. So that's why, like, that hand holding, that handshaking gesture can be done. So every customer is unique, every customer has again a unique problem. So 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 that level of the customer also depends on their engagement on the technology front itself. So if there is a very skeptical customer, he will be skeptical in any of the technology. He will not only be skeptical in additive, he will be skeptical in any of the manufacturing process itself. And skepticism is good because it lowers down your expectation also. So but lowering down your expectation creates another kind of a fuss for yourself. So taking example like ISRO, HALs, taking example of any of the automotive, all two-wheelers, four-wheelers, automotive, they have they had a wonderful journey through additive manufacturing itself. They have very big workshops, so they understand about the technology really good, really better than us. Sometimes they also teach us, Ankit, you have to do something like this in this format itself. So all the answers are not with the supplier itself. It is a collective and a formative approach what we need to take in taking up any of the project and giving out any of the bespoke solution into it.
Yeah, thank you for experience
So
sharing. And
what I'll do is,
yes,
like, I will answer the Q&A questions uh, through typing in these answers. So that
okay,
would be better, I think.
sure.
Then we can
Yeah.
take those questions. If you still have those questions unanswered, we can take up in on 8th at 5 p.m. Okay.
Okay. Yeah. So now we officially release people. So thanks for joining. And the session has extended a few more minutes because of the curiosity and interest that you have shown. And we really appreciate your engagement. And we are really overwhelmed with the curiosity as well. So we will go through your queries and answer one by one. But you are free now to drop the call and resume your daily activities. So thanks for joining. And uh, as a last departing message, that Ankit shared the experiences and all. So next presentations that we are going to make are more on solving some of the unresolved answers, but stay with us for uh, getting answers. And as well, you can engage one-on-one with our marketing and sales team. So that's the last message. Thank you so much for joining. Yep.
Thank you so much.